In this video, we will be discussing about multivariable process and how to control the multivariable process using decentralized control and centralized control. So here we will see the block diagram representation of a multivariable or multi-input multi-output process. We will discuss how complex is the multivariable process. We will discuss the centralized control versus decentralized control, and we will extrapolate the control strategies in single input single output process to multi input multi output process. So when we say a multi input multi output process, it can be represented in block diagram like this. Okay, here we are having a process, as we know what is a process from our last lectures, and here we will be having multiple number of inputs as well as multiple number of outputs. So here U represents the inputs, and generally we will say there are n number of inputs, and Y represents outputs, and say we are having m number of outputs. So this is a n by m process. Okay, n by m process, that means there are n inputs and m outputs. Okay, so the inputs, as we know, I mean, there will be form of mass, energy, or momentum or information to the process. Similarly, there is the case for the output. Now, among the output, okay, among the M output, some of the outputs will be having some economical values, okay, like concentration, quality, quantity, etc. So we may need to make sure that those particular output, or some of them may be having some safety importance, some of them may be having some uh, environmental regulations kind of thing, and some of them will be directly related with the product. All these need to be maintained satisfactorily. Okay, so we will select some of the outputs to control or to be controlled to a particular desired value, okay, which we call it as the set point. So those outputs are the controlled variables, okay, and among the inputs, some of the inputs, okay, depending upon some qualities, we will select to control the controlled variable, okay, such that by manipulating the manipulator variable, okay, or manipulating the so-called selected input variable, which we call it as manipulator variables, we can control the controlled variables. Okay, definitely in most cases the other non-controlled output variables may be also get affected by changing the manipulator variables. Okay, so we have to, first of all, among the n inputs, we have to select the manipulator variables. Okay, and the remaining inputs, okay, they will be also be affected, they will be also changing with respect to time, maybe because of external conditions. They are called the disturbance variable or load variables. Okay, so the inputs can be divided into two. Okay, some of them are the manipulator variables, which will be manipulated by the controller as per the decision of the controller, and the remaining will be the disturbance or load variables. Among the output, it can be classified as, say, control variables, which are having some significance, which need to be maintained at some certain set points. Then the remaining, among the remaining variables, some of them also we will use for controlling other control variables. Okay, so for controlling purpose we need to measure the output. So as I have told, some of them will be the control variables like concentration, flow, and all. But in some cases, say for example concentration, it is very difficult to measure concentration instantaneously. So what people do, they will infer the concentration by measuring some other related variables like temperature and all. Say in the case of a distillation column, the output, concentration is very important. It is a time-taking process. Measuring the concentration is a time-taking process. So what we usually do, there will be specific plates, maybe 4 or 5 plates. Temperature of these plates will be measured. Okay, these are also output variables. Then mathematically we will find a correlation between the temperature of these 4 or 5 plates and the concentration. Okay, so temperature measurement will be very easy. So in that way we can infer the concentration by measuring some other variables. Okay, that is also possible. Now, how these control variables, manipulator variables and measurement variables are selected? There should be some reason for their selection. First, let us see the selection of control variables. Now, as I have told, the control variables need to be maintained at some certain set point. So how it is done? It is done by manipulating the input. So when the input get manipulated or input get changed, the effect should be visible in the output or the so-called control variables. So it is very important that the selected control variables should have high sensitivity to the changes in the corresponding manipulator variables. Now, among the inputs, there are two kinds of inputs. One is the manipulated inputs, and the other one is the disturbance or load. Now, it is also very important that the selected control variables should be least sensitive to the disturbances. It is very straightforward. Now again, it is very important that the control variables should be easy to measure and control accurately. Also, the correlation with other control variables should be minimum. That means when we are changing one control variables, say y1, the effect of y1, the effect of change of y1 in other outputs like y2 to ym should be minimum. Okay. Now, how we will select the extra measurements? Okay, other than the control variables need to be measured or it should be inferred. So, what are the measurements or what are the additional measurements we need from the output variables? It is required to ensure the observability. Okay, observability is to know the status of that particular variable from the starting. Then, yeah, so we have to select the inferential variables in such a way that they introduce only minimum uncertainties in the inferential relationships. That means if you are using, say, temperature measurement for inferring the value of concentration, they should the temperature that we have selected combinedly should give only minimum uncertainty in the concentration. Okay, the error should be very less. Now the measurement delay should be very minimum. Okay, that already we discussed. Say concentration, it's the measurement will take a lot of time. It's a delay process. Measurement delay is high, but in the case of temperature, the temperature measurement is a very fast process. Now, if you are using temperatures as inferential variable, the way the we can interpret the concentration without much delay. Okay, we have to find some mathematical relation said that the concentration is a function of temperature 1, 2 and 3 and 4 kind of thing. Now, how to select the manipulator variable? The most important thing is that you have to ensure the controllability. That means by changing this particular manipulator variable, the intended output should be taken to the desired value. Okay, so this manipulator variable is having the capability to take or shift the output value from the present value to the desired value. Okay, that is very important. And if the manipulator variable is having a one-to-one relation with any particular control variable, okay, that is a golden relationship. Okay, so if there is only one-to-one relation, say if input 1 is having relation with a direct relation with output 2, and if it is not having any relation with any other output, we will say that the interaction is nil. The interaction of the input 1 on any other output is 0, and it is having a direct relation with output 2. So what is the advantage? Without focusing on any other output, we can change the input 1 to take the output 2 to the desired value. Okay, and it is very important that the cost of operation should be very minimal. So when we discuss this point, I wish to emphasize that in process industry, we will give preference to flow as a manipulator variable. There are many reasons. One of the main reason is that the cost of operation is minimal, and another important reason is that the flow can be adjusted very fast. Okay, say flow by using a valve, we can adjust the flow from 0 to 100% within no time. Okay, so that is the criteria for selecting the manipulator variable. Now this representation is very much familiar for you people already, those who have studied the control system. So this is a single loop control system, okay, where we are having process. Okay, it will get affected by disturbances, and we will be having final control element. There will be a controller, and there will be measurement setup. So the measurement setup will give the measurement, take the measurement. It will compare with the desired value. Based on the error, the controller will give some control action, control decision, and through the final control element, the control decision will be implemented in the process. Ultimately, what is the objective? The objective is to take the output y to the desired value. Fine. Now, this is very simple system. It is having only one control variable, and it is having only one manipulator variable. Okay, here the manipulator variable is the u, okay, and y is a single control variable. Now there are a number of process variables which must be controlled, and a number of which must be controlled, and a number of variables which can be manipulated. Yeah, usually in real life this is not the scenario. Okay, we will come with process which will be having many inputs and many outputs. So this so-called representation may not be always satisfying. Now we have to find control strategies which will take care of multi-input, multi-output control system. Okay. So before going to the multi-input, multi-output system, okay, that means which are having many inputs and many outputs, I wish to take you to a simple shower dilemma. Okay, so in winter we used to take shower using geyser. So what actually happened many a times when we adjust the shower valve, mostly we will feel chilling cold, or sometimes it will be burning hot. Okay, because we may not be able to adjust the flow of hot water and cold water correctly in the starting of the shower. So this is a problem which we will face most of the time. Now if you just see at this problem, the shower problem, what are the inputs? The input is the flow rate of the hot water from the geyser and the flow rate of the cold water, which is from the normal pipe system or from the tank. And what about the output? The output temperature is one output, and the flow is also an output. The flow from the shower is also an output. So basically we can say that it's a two input, two output system. Okay, even we can make it more complex. Provider in this case we are taking some assumption. What are the assumption? The temperature from the geyser is a constant, maybe say 70 degrees centigrade, and the temperature from the tank is also constant, say something like 5 degrees centigrade kind of thing. Okay, so keeping this temperature, the input temperature constant by using that assumption, what are the variables? The input variables are the flow rate of the hot water, that is from the geyser, and flow rate of the cold water, that is from the tank. Okay, and what are the output? Output is the temperature of the water that is coming from the shower and the flow from the shower. Right? Now, cracking the two handle shower wall. Okay, there are, in the old, conventionally we were having the two handle shower wall. You may be remembering that in most of the Indian buildings still we are having that two handle shower walls. So one handle is to adjust the hot water flow rate and another handle is to adjust the cold water flow rate. And it's a trick to control the temperature and flow of the water in your shower. Okay, and many of us still are finding it difficult to get the right temperature and flow rate. So still a mystery. Now, what is actually happening if you're adjusting, if you are feeling that, say, the hot water, if the temperature is very hot, what we'll do, we will either reduce the hot water flow rate. In that case, what will happen? The total flow rate of the output will come reduced. Okay, so what we can do this, we may increase the cold water valve. Then what will happen? The flow rate will increase, but along with that, the temperature of the output water will come down. Okay, so it's really interacting. Okay, it's a really complex problem. Now I just want to increase the dimension to this problem. Okay, so if there are two people taking shower together and one person is taking care of one wall and another person is taking care of the another wall, and provided there is no communication between the two people, how difficult will be the situation? So one person, he will feel that the temperature is high, so what he'll do, he will increase the cold water shower. Okay, he is not knowing that what the other person is doing, but the other person who is in control of the hot water shower or hot water valve, whether he is going to increase or decrease. So at the same time, if he is also decreasing, so what is going to happen? The temperature will come down. Okay, so what is going to happen then? Then both of them will increase the flow rate. So this will be really conflicting. Okay, and this is a very difficult problem to solve. Okay, so provided in these are two cases. In the previous cases, a single person, that means that person is getting the temperature and flow rate through the skin, then sensing is possible. Okay, and it is very clear that he is taking the decision. Okay, that means a single brain is taking the decision here. Okay, there is no need of any communication. But in the second problem, two people are taking the measurement, two people are controlling it. That means two brains are behind this action. So when there are two brains or two controllers, you find that how complicated the situation is. Even though the first situation is also complicated, and the second situation become more complicated. Okay, so the first example, when a single person is controlling it, we can call it as a centralized control, and when two people are controlling it, we can call it as a decentralized control. Fine, we will see it with a general case later. Now for your information, because of this burning problem, the International Building Code is no longer permit the use of two-handle shower walls. Nowadays, you can find in good hotels and all, there is a single valve to adjust the flow rate and temperature. Okay. Now, if you are analyzing the two faucet shower system, okay, there are two valves. One valve to control the hot water flow rate, the other valve to control the cold water flow rate, and that there are two outputs. One is the temperature of the output water, and the second one is the flow rate of the output water. Here we are having an assumption. What is the assumption? The hot water temperature is a constant and the cold water temperature is also constant. Fine. Now, this is the relation. This is how the relation exists. Mathematically, we can show like this. Schematically, we can show like this. So the hot water flow rate, okay, it can affect both the output temperature and output flow. Okay, say the mathematical relation between the output temperature and hot water flow rate is G11, and the mathematical relation between output flow rate and the hot water flow rate is G21. Okay, so this is the mathematical relation. Similarly, we can find that cold water is also affecting both temperature and flow rate. Okay, in other sense, the temperature is affected by both hot water and cold water flow rate. The output flow is also affected by both hot water and cold water flow rate. Fine. Now, in a single centralized controller, both are adjusted simultaneously. The hot water and cold water are adjusted simultaneously to get a satisfactory temperature and flow rate. But in the case of decentralized control, it is one-to-one connection. Say hot water will be connected to say temperature and flow rate will be say manipulated by cold water, or it can be the other way also. So how to do the pairing? Okay, if the hot water is paired with the temperature and cold water is paired with the flow rate, we will call it as diagonal pairing, one-to-one straight diagonal pairing. If hot water is paired with the flow rate and cold water is paired with the temperature, we will call it as off diagonal pairing. Okay, so whatever be the pairing, first of all we have to find, okay, which way we have to connect the controller, whether it is diagonal or whether it should be off diagonal. So there should be some science behind that. Now coming back, so we have seen there are two kinds of control strategy. One is the centralized or multivariable control strategy, and the second one is decentralized or multi-loop control strategy. Okay, so in the centralized control, all the manipulator variable is designed for so each manipulator variable is designed for two or more of the control variables. That means every manipulator variable will affect every control variable. But in multi-loop control, each manipulator variable is designed for only a single control variable. Even though there will be affecting, whenever you may change one manipulator variable, because of the internal relation, it may affect more than one output. But from a control point of view, the controlling of one control variable will be done by one manipulator variable. What about centralized? Control of two or more control variable will be done by every manipulator variable. Fine. So we can generalize the MIMO process like this. Okay, this is a simple example of a MIMO process which is having two outputs and two inputs. Okay, so you can see that each input is having a relation with each output. Okay, so G22, it is the relation between output 2 and input 2. G12, it is the relation between output 1 and input 2. Okay, so it will be something like Gij. Okay, I stands for the output and J stands for the input. Fine. Now, this is the case of a multivariable control. Okay, that means we are having a single controller. The single controller will be fed with both the desired values. Okay, in the case of 2 by 2 process, that means a 2 controlled variable process. The desired value will be fed to this single controller. This single controller will get the measured value from both the control variables. Okay, and there will be some calculation that will happen within this centralized control, this single controller, and it will instruct this final control element, if C stands for final control element 1 and final control element 2, to make changes in U1 and U2 simultaneously to adjust Y1 and Y2. Okay, so here what is actually happening, single controller simultaneously manipulating the manipulator variables such that all the control variables are simultaneously controlled to the desired value. Fine. Now, what are the advantages and disadvantages of centralized control? It is very clear that we are having only one controller. Okay, if something happened to that particular controller or something happened to that single brain, everything will be uh, damaged or everything will be become unstable. Okay, so you have to understand, if this controller fails, at the same time this loop will fail, at the same time this loop will fail. So usually what is going to happen, so when this controller fails, you need people to take care of this controller, you need people or manpower to take care of this Y1, you need people to take care of Y2. So the requirement of manpower at a failure is very high. Okay, that is also a very important thing. Now, what are the advantages? We will discuss it once again. The advantages will be, the single controller knows the status of all process variables. There will be better coordination because a single person is doing it all alone. And a better optimization is also possible because a single person can, the single controller can mathematically optimize Y1 and Y2 along with U1 and U2. Okay, so there will be faster response provided the controller is having enough computational power. And another important thing is the minimum hardware requirement. Okay, the wiring will be very less required. You need only one controller or one computer to control the entire process. Now, disadvantages. In case this controller fails, it's almost a chaos because along with the controller, everything else will also fail. So we need better interlocks, emergency interlocks or safety interlocks. So in case of this failure of this controller, there should be some strategy to take care of the emergency condition. Now, this need good process models, okay, because in single input, single output control, the relation is between Y1 and Y1 and U1 or Y and U. Here, we need the model, we need the relation between relation Y1 as a function of U1, U2, U3 like that. We need Y2 as a function of U1, U2, U3 like that. So the mathematical model requirement in developing the control strategy will be little more complex. Okay, or we require better model for developing good controllers. Okay. Now let us think about a single case from our institute. Assume that the vice president of Gymkhana trying to organize the technosis by his own. How difficult it will be. Okay, he has to take care of multiple things, phone calls, multiple programs. Is it going like that? No, we are having a very well organizational structure. Okay, so the success mantra when your problem is big is delegate, delegate, and delegate. Okay, this is a very important success mantra. Now let us discuss about decentralized control. What is decentralized control? So in decentralized control, as I have discussed, this output Y1 will be controlled by a particular controller which will take care of either U1 or U2. Okay, that means there will be a dedicated input for Y1. Okay, so assume that if U1 is the dedicated input for Y1, naturally the dedicated input for Y2 will be U2. So that is, as I have discussed, that is the diagonal form of control. If the dedicated input for Y1 is U2, naturally the dedicated input for y2 will be u1. We will call it as off diagonal pairing. Okay, that means in decentralized control there is a pairing of output and input. So there will be, in this 2 by 2 process, instead of one controller there are two different controllers. One controller manipulating u1, another controller manipulating u2. Fine. Now the biggest question in decentralized control is which input variable should be used in controlling which output variable. Okay, so the question is whether y1 should be used for controlling y1 or it should be used for controlling y2. Whether we should go for diagonal pairing or we should go for off diagonal pairing. There should be some reason behind the selection. Now let us see a simple 2 by 2 process. That means 2 input 2 output process. Okay, that means 2 manipulator variables and 2 control variables. So the different input output pairing combinations are the configuration 1, which is the u1 used for y1 and u2 used for y2. That is the diagonal pairing. Or we can go for configuration 2, where u1 will be used for controlling y2, or then naturally u2 will be used for controlling y1, which is we will call it as diagonal pairing. So a 2 by 2 process, two different possibilities are there. Okay, so what about an n by n process, which is having n inputs and n output? How many different configurations are possible? Can you think? For your understanding, a 5 by 5 process, there are total 125 configurations are possible. The input and output can be paired in 125 different ways. Oh, it's little big. I mean, many in naturally in industry, a 5 by 5 process is normal. Okay, 4 by 4 or the 5 by 5 process are normal. So a 5 by 5 process, there are 125 different pairing possibilities are there. So selecting one pairing possibility or one right pairing possibility from these 125 different combinations is a bit complex process. Now, as I have told, in multi-loop control, we will be having a dedicated controller for u1 and a dedicated control for u2. Okay, so here I have shown a diagonal pairing. No, here it can be other way also, no problem. This is a diagonal pairing. Why it is diagonal pairing? Because u1 is controlling y1. You can see that y1, the measurement from y1 is fed to the controller 1, and the controller 1 is taking care of manipulating u1. Similarly, the measurement from y2, output 2, is fed to the controller 2, and the controller 2 is used to manipulate u2. Okay, so desired value for y1 is given to controller 1 and desired value for y2 is given to controller 2. Okay, obviously. So this is a you can see, we can call it as two single input single output process, or we have decomposed the multi input multi output process into two single input single output control strategies or controller. Fine. Now what are the advantages and disadvantages of this multi-loop control? Okay, the interaction part I will discuss in the next video. Now let us discuss about the advantages and disadvantages. Possibly you may be able to answer that. What are the advantage? Advantage is, if by any chance, if any controller fails, okay, say for example controller 1 fails, we require manpower to take care of this controller and y1. Okay, y1 we can control manually because already controller 1 fails, it cannot take care of y1. What about y2? There is no problem. y2 will be taken care by this controller. This controller will be in good shape. Okay, so we don't require any manpower to take care about y2 or this second controller. Okay, So in case of any fault, the tolerance limit will be very high in the case of decentralized control. Okay, the tolerance level will be very high. Maintenance will be very easy in the case of decentralized control. Okay, if you want to do some maintenance in this particular loop, you can open this loop. You need some manual control here. You can correct what is the problem in this particular loop. Come back to the closed loop, run the plant. You should not worry about the remaining loops. The remaining loops will run automatically by the controllers. Now, what are the disadvantages? Definitely, the investment should be high because we require more controllers, we require more wiring, we require more equipments. The investment in the investment, the initial investment will be high. Okay, so that is one of the main disadvantage of decentralized control. But considering the advantages, decentralized control is having a upper hand over centralized control in process industry. Now, let us conclude this lecture. So we have seen multivariable process, we have seen centralized control, we have seen decentralized control. And what we have seen is the decentralized control or multi-loop control is an extension of a single input, single output control or loops. And when we select the decentralized control, interactions, okay, this interaction part I have not discussed in this video, that is very important. And whether it is diagonal pairing of or off diagonal pairing in a 2x2 process, the interactions play a key role and it should be taken care. Fine. So there are some suggested readings, chapter 20 from Babatunde and chapter 3 from this multivariable feedback control by Suggested. Now in the next video we will be discussing about multi-loop decentralized control, which input variable should be used in controlling which output variable. So that means we will discuss about the interaction analysis. Fine. So thank you very much.